This is continuing on looking at some of the basics of C Sharp. I'm going to do a file new project. And remember, you need to choose Visual C Sharp if it's not already selected. So you got a Windows desktop here. Now choose Windows Windows Forms app. In case you're wondering what a lot of these other items are, you can create libraries, services, about any type of program you can imagine. You can create with Visual Studio. If I come up to the all here, it includes apps, not just for Windows but for Android. I think you can create it for iOS also. It's a little bit tricky since we're on Windows. You have to connect this to some kind of Mac machine. And there are machines available out in the cloud that allow you to do that. But they've tried to include everything you might want to do. Okay, back to Windows Desktop and choose Windows Form app. And I'll just call this example program. We looked at last time creating an application where we, I think we did the force equals mass times acceleration. At least we did some kind of physics formula. And we'll leave that alone. Remember, you can resize it by grabbing these corners down here and pulling it down. You can also come over here, and for your size, you can change the numbers here. So if you try and get precise values, then this is how you can do it. Okay, now I'm going to drop on, just to review, I'm going to drop on some labels and text boxes. And let's see, where's my text boxes? As you move these, again, you'll see lines appear that help you to line up what you want. I'm going to do a rectangular select, so I clicked up here with my left mouse button, held down and dragged, so all these are selected. And once you have those selected, you can change the items that are specific to all of them. Now you notice that there's less properties over here. That's because it only picked the properties that are identical in label and text box. So the more items you choose, then the less options you'll have here. If I take font, I change it to 14. You click outside of it to unselect those. Now I have this selected. I'm going to type something in there. And I'll just do force equals mass times acceleration again. So this will be mass. And I guess text isn't, size. So okay, come down here to text. Mass. Change this one to acceleration. Change this one to force. And change this one to 0. And I'll make it invisible to begin with. So come down here, double click that so it's not, you can't view it. Okay, so after they put in the mass and acceleration, I then want to calculate. So I'm coming up here, I'm going to rename it. Come up to the name. I'll call this TB underscore mass. And I'll call this TB underscore acceleration. And this one I'll call LB for label. LB underscore force. Okay, so keep in mind what those names are. The name of the form up here says form 1. I'll just click in the gray area here and do force calculation. Oh, name. Okay, let's try that again. Where's text at? Force calculation. Now, before we put a button on here, I want to demonstrate this just so you start thinking besides just button clicking. You can put code anywhere. So, for example, on the acceleration here, if I come over here and click the lightning bolt, this is events. This is everything that I can program. For example, here's a leave. Occurs when a control is no longer the active control. Let's try to do that one. So I'm going to, over here under leave, I'm going to double click the white area next to it. I had to click it again. First time put the name in there, second time. Unless I just didn't double click it the first time. Okay, so I'll come over here and I'll declare some variables. These are going to be double. Remember, double is a number with decimals, or can have decimals. And this is going to be mass, acceleration, force. Our mass is going to equal to double dot, and you think I would remember this. Type it 100 times. I think it's parse, not try parse. Let's try parse, see if that works. And then I'll do TB underscore, let's see, this is mass, dot text. And acceleration is going to equal to double dot parse, TB underscore, acceleration dot text. Force is going to equal to mass times acceleration. Then my label dot text is going to equal to force dot toString. And I won't go over that because we've gone over what all those commands do. Keep in mind we've looked at integer.parse quite a bit. Double.parse is same format. It just will convert it to a double, a number with decimals, or it can have decimals. Now I have to make my label visible. So LB underscore force dot visible equals true. Now, true is a Boolean. It's true or false, like a yes, no, 1, 0 type of setup. It looks like what you use in 4 characters there. Why don't you just use something else that looks smaller? Well, this is actually a pretty small element in terms of data storage. Okay, let's see if I put it in the right place. Maybe I didn't put it in the right place for the leave. Sometimes I have to play with that to see which one it should be in. Okay, so put 5 here, 2 here, and I'll do a tab. And see how it automatically updates that. If I change 7 here, it didn't automatically update that. So maybe what I want to do is anytime I leave either blank, I want this to be updated. Now if I do a tab right now, it'll update it. Which means I want to copy that code and put it into the other location. So if I come here and I click mass and I go to my leave under my lightning bolt. So right here, I'll double click that. It'll open this up and then I can copy all this. So I highlighted it, I right clicked on it, chose copy, I'll right click down here and choose paste. Now we're going to see something happen here. It's not going to work right. I put a 3 in here, and then I do a tab. Comes up with a bizarre error. It says input string was not in the correct format. If you ever have this pop up, don't just immediately stop it by pushing the little square here. Come up here and investigate it. If I put my mouse up here over TB underscore ACC, you see it says text equals empty string. And if you think acceleration was my second box, and that's true. I haven't put anything in that yet. Now I can put my mouse over this, and I see that's equal to 3. So it looks like maybe I want to do some checking to see if nothing's there. If nothing's there, I don't want to necessarily do this calculation. Because it tried to convert a empty string to a double, which it doesn't know how to do. So we have to handle that appropriately. So I'm going to go ahead and stop the debugging here. And we got another issue because we repeated the code twice, which means we got repetition. We have a mechanism to handle that. If I come up here, I'm going to create... This right here is called a method. And we're going to create our own method that we can call from here. Now, I might have to play with this a little bit. I'm not sure if I need public there. I don't think I do. But let me do a void, and I'm going to say calculate. And then I'll put force. Beginning parentheses, closing parentheses. And then you have to have a beginning curly bracket, closing curly bracket here. Now, instead of having this code in 2 places, I'm going to cut that. I'll paste it here. And down here, I'm just going to get rid of this code altogether. As you delete code, you want to make sure you don't get rid of those curly brackets. Now, from within each one of these, it's going to call this method. So calculate force, and this one here will be calculate force. The benefit of this is I could call this particular method here in 100 different places in my program, and then I'd have just the call down here. All the code would be in one location. So that if I needed to make a change, I just come to this one location, which I'm going to do here shortly. I just come to this one location, I make the change here, and it's by default propagated throughout my entire program. If I go to command prompt, and if I go to IP config, comes down here, gives me IP addresses to help identify who in the world I am. Now, it used to be we just had the IP version 4 address, this down here, the 192.168.206.1. And then they didn't make this big enough. I think especially when China went online, that quickly exhausted the numbers here, and they needed something else. So they came out with this the version 6 for IP addressing. Oops. I don't know what I did there. I think I right-clicked and chose paste. But they came out with this version 6. Well, if they had to visit every machine, that would not have been practical. They would visit every machine across the entire world. So what they did is they changed this in a central location, and then it spread out to all the different machines. That's the idea of a method for that purpose, is that you have it in one place, and then you can then call it from multiple places. This is even more if we were to expand this. Like if I like this, I could put it into its own little, we'll call it a library, which means it's a piece of code here that you can then, when you start a new program, you can use that code. And that already exists. I don't know if I can actually see any of them, but if I right-click on double here, if I go to, what is it? Go to definition. I think go to definition. This is how they have defined double. So they've done all the coding behind it. You won't see any of the code here. I think these are just the header information. Like if I expand this parse here, see how it just gives a summary. There's no code there. This is code that other people have written such that I can then use it. Now this is how big your double can be. What that means is negative 1.79769 and so on times 10 to the 308 power, which means you can move your decimal point 308 places to the right. Huge number. You'll find that there's other data types too, besides double. There's float. If I come back here and I define float, test one. I right-click this and go to definition. You notice that it only goes up to 38, so it only moves at 38 decimal places. Where the other one went 308, so it takes up more memory. Some people will use float, and if you're in another class, you may have seen that. We use float a lot in the game development. The reason why is just it conserves memory. So if you have this huge of a number you're working with all the time, then just creates headaches in terms of the memory. You might say, well, why aren't you worried about memory here? Well, some people are. I tend to throw doubles around a lot, but some people will use floats because they, in a lot of cases, will accomplish the same task. As I scroll down here, you see there's parse here, 4 parses. And this one says a string. This says one says a string, and then you got a number styles, whatever that is. Again, I can right-click on that and go to the definition, and that'll show me how that's defined. But anyway, this is extra code that they're bringing in. And that's what you do with this. You'd put it in its own little library somewhere, and then you would import it in up here. Okay, now it's still got a problem. If I run it, it's still going to break. If I put a 3 here, do a tab, comes up with the same issue. Reason why is we need to check to see if it's blank. Different ways you can check to see if it's blank. Let me get rid of that. First off, you can just bring it in as a string. So, how I declare a string is string, and then I'll do string underscore mass. Wait a minute, what am I calculating? Mass equals force equals mass times acceleration. So mass is good. I'm bringing that in, and string underscore ACC. Now, instead of doing this conversion in the same step that I'm bringing it in, I'll do it in 2 separate steps. So I'll say string mass is equal to tb underscore mass dot text. And string acceleration is equal to tb underscore acceleration dot text. Excuse me. So now, down here, instead of putting in tb underscore mass text, I'm going to put in string mass. And down here, string acceleration. Now you might say that didn't accomplish anything. You bring this in, you're assigning it to a string. And then you're still doing the double parse on the string. Now if I run this, it'll break again. So I haven't changed anything. But now here I can do an if statement. And there's a problem with this if statement, which I'll talk about. But I'm going to say if string mass is equal to 0. No, not 0. It's equal to empty string. Wasn't right when it came out. How do you want to handle that? You got your blank there. Do you want to put a 0 in there for it? Well, it could be. So if it is, then maybe you want to say that your mass is equal to 0. Now an else statement. Talk about that here in a minute. I don't think I want an equals equals. If I remember right in C# now, it's dot equals. We'll try that to see if it works though. I don't think it will. This is checking to see if it's equal to an empty string. If it is, then it's setting mass equal to 0. Otherwise, it's setting mass equal to double dot parse. It's converting whatever is in a blank to a double. Let's put the same code down here. If string acceleration is equal to empty string, then I'll say acceleration is equal to 0. Else, acceleration, oops, I don't need to type that. Delete. Else that. Okay, now let's check to see if I'm right about those equals equals. Okay, so I'll put a 3 here, do a tab. Yeah, that's what I expect. If it's assuming 0 for acceleration at this point, 3 times 0 would give us 0. Now if I put 4 in here, it works. If I put numbers in there, I see that I can keep putting numbers in there and it automatically updates those. Now this is assuming that you want to put a 0 in there. You could handle it differently. It's kind of however you want to code it. Maybe if there's spaces in there, you just don't want to calculate at all. In which case, you'd have to do a little bit of maneuvering here to get it to work. Questions on any of that? Okay. Couldn't say that. And I'm going to calculate something else. Quadratic formula. Don't worry about necessarily what the quadratic formula is. I'll give you the form of it here in a minute. And I actually like buttons, so I'm going to put a button on there. I just wanted to show you an example to demonstrate you can put the code behind anything. It's kind of your choice when you're designing something. You come over here to your little lightning bolt. You can program any of this. Now, if you ask me what some of these mean, I have no clue. You'd have to, go off and some of them is pretty obvious. Like some of these, like mouse. That's when your mouse is over the item, and when your mouse is not over the item, that's a different event. I could guess on some of these. Mouse capture change. No clue. Mouse click. That's pretty obvious. You clicked. Mouse double click. If you double click something, that's how you can program it. Mouse down. I think that's when you push and hold down on the mouse button. Mouse enter. I don't know. I'm guessing mouse down is when you push down. Mouse enter is when you go up. Hover, I have no clue. Mouse leave probably is when it's no longer over the component. And again, I'm just guessing. Now you can click these, and you see it will put the description down here at the bottom. Mouse leave occurs when a mouse leaves the visible part of the control. So when your mouse is no longer over the button, for example. There's kind of a clever little program that they sometimes write, demonstrate programming these different events, is when your mouse is over a button, it moves the position of the button. And it uses random numbers. We haven't talked about random numbers yet. But that way, every time you try to click the button keeps moving around on you. Yeah, it's kind of a little clever one. Hover. Occurs when the mouse remains stationary inside of the control for an amount of time. So if you put your mouse over a button and leave it there for a period of time, then this occurs. Okay. Now I need A, B, and C for my quadratic formula. Don't stress. If you've never had algebra, that's fine. I don't require you to have algebra. Anything I give you will just be the formula. It won't really require any extra knowledge on your side in terms of math. Okay. 3, 4, 5, 6, 7. 3 text boxes. And 1 button. And let me go ahead and change the font on all those. Well, there it is, properties. Okay, font. $16. Again, if I wanted those to all be the same size, I could click up here in a gray, drag and drop. I'm holding down my left mouse button. I lit up there, selects all of those, and I could change the size of that. Oh, I'm in the font. Okay, let's try it again. There it is, size. Width, change that to 300. So if and you notice that these are not the same distance apart. If I again highlight those, remember there's these, and I couldn't tell you which ones. I'd have to play with them and see. Align centers might be. Make the same height. Make horizontal space horizontal. I almost think it's vertical. Make vertical spacing equal. There you go. If you click that, you see that now they're equal distance apart. Okay. Labels, doesn't matter where I put them. It's just going to say something. Up here anyway. You see I put a lot of effort into lining everything up as I'm dropping it. You don't need to do that. If you use these, and if you get comfortable with these, and you can very easily. Like if I don't got that quite left aligned, there's one of these that, what's this one say? Align lefts. So you can very easily do it. Don't ask me why I spend so much time lining them up then. Okay. I just moved that one. Okay, so I'm going to change that one to A. This formula requires you to bring in 3 letters, A, B, and C. So I'll name that A. Actually, I'll name that TB underscore A. Or, what am I doing? That's a label. Whatever it was equal to. Text is what I'm looking for. Okay, A, B, C. This one, X1. And this one's going to be X2. Now I'll give these names. This one will be called, if I come up with a name, this will be called TB underscore A. Normally, one letter variable names aren't good. TB is just for the text box. But in this case, it actually makes sense since that's what our formula is based upon. TB underscore B. And TB underscore C. I want the button to say calculate. I think probably the greatest benefit of, well, I shouldn't say greatest benefit. One huge benefit of, I'm going to label this LB underscore X1. One huge benefit of Visual Studio when it came out is it could be used for prototyping. You could go through and design what your form's going to look like without putting any code in it. Okay, I want this to say 0. And I want to say 0, 0. Now I'm going to highlight both of those and make them invisible. So I change visible to false. Like that. And I'll click the gray area here and I'll change my text to say quadratic formula. Now if I run it, that's where you come up here. And this is where you can give this to your users and say, is this what you have in mind? 3 boxes, text boxes here, a button for the calculate, and this doesn't go down far enough. That's interesting that it didn't go down far enough because on the screen it looks just fine. So I'm going to go ahead and move that down so that it actually looks good. And now let's go ahead and click start. That is strange. It keeps resizing. Oh, thank you. I'll have to think about that one. Because the size here is size it should come up as default, but it's changing it. It's easy enough. I can move everything up. Better not move that up. Let's try it again. Interesting. Now you can program it such as maximize to begin with. I think you can program it so it's minimized. We'll eventually get to those. But I'm a little bit puzzled about that part right there. But anyway, what I'm trying to program. The quadratic formula. And this is what the quadratic formula looks like. That's a square root. So we got negative b plus or minus square root of b squared minus 4ac all over 2a. Now you don't need to know any kind of math. You just need to know how to program these different operations. 2a, that's 2 times a. When you got a fraction, you put parentheses around top, parentheses around the bottom. and we'll see how to handle power, and it'll see how to handle the square root. So this one demonstrates a lot of different operations we can do on numbers. Okay, so I'm going to go ahead and double-click Calculate. Remember, that goes to your default event, which in this case is a button click. I'm going to declare some doubles. And actually, I need x1, x2. Those are going to be my answers. Now, we need to retrieve A, B, and C. And I could do some error checking on this if I want. I could check to see if anything was input into the blank. And as we get further on in the semester, you should put that as default in every code you write. It's not as critical right now. Okay, A is equal to double dot, I think parse actually worked instead of try parse. And I called it TB underscore A dot text. B is going to equal to double dot parse. TB underscore B dot text. C is equal to double dot parse. TB underscore C dot text. And that's curious, it didn't change that to uppercase P. It is case sensitive, so if you're having trouble with your code and it's giving you a little red squiggly, it could be you got to run a case there. Okay, so now I brought in A, B, and C. And this plus or minus is why I got x1 and x2. Because that plus or minus means negative b plus this over 2a. And it also means negative b minus this over 2a. Okay, so I'm going to say x1 is equal to beginning parentheses for the top. So you have to have parentheses around the top. Negative b, I'm going to do a negative 1 times b plus, now square root. If I type math dot, this is how you bring in all the math libraries. You see a lot of different ones here. There's some trig ones. This is how you round, and we'll take a look at that eventually. Remember we had that issue where we put in something that had a lot of decimal places? Well, you can round. Min, max. Okay. Anyway, I'm going to choose square root. So you can double click it here or press enter on it. Do a beginning parentheses. And it's telling me it's looking for a double. If I had declared them as floats, then I would have to do some kind of conversion. I don't think it would have took that directly. And then we're going to have b squared. Now, there's two different ways you could do that. You could just simply do b times b. That's b squared. Some programming languages allow you to do a caret. I don't remember if Visual C Sharp allows you to. Doesn't look like it. See how it gives me a little red squiggly? Okay, cannot be applied to operands of type double. So you got two choices. You got b times b, that'll give you b squared. The other one is if you go back to math dot, you see there's a pow function. And what this does is it'll raise a number to another number. So I could do b squared. Now notice we're starting to get a lot of closing parentheses here at the end. So it can get confusing. But we're now done with b squared. Minus 4 times a times c. Closing parentheses for the top. Or no, that's closing parentheses for the square root. Never mind. Notice how I put the closing parentheses there, and it puts a shading on what it applies to. Now that has become invaluable when they added that feature in. And then, if I do another closing parentheses, it illustrates that matches up with the one for the top. Divided by beginning parentheses, you put parentheses around the bottom, 2 times a. And you see it puts spaces in there. It tries to format it the way it thinks is best. So the next 2 is going to equal the same thing, negative 1 times b, this time minus math.square root, math.pow, b2, Minus 4 times A times C, closing parentheses, that's closing parentheses on the square root, closing parentheses on top, divided by 2 times A. Now, assuming I put all my closing parentheses in the same place, or the correct place and everything, that's correct. We need to write it back out to our form. Okay, so I'm going to say x1, what do I call it? No, the LB underscore x1 dot text is equal to x1 dot toString, and LB underscore x2 dot text is equal to x2 dot toString. Now, I've specifically put all of this in here into this program for the quadratic formula. Well, quadratic formula probably hasn't changed for 200 years, whenever they came up with it originally. So that, they came up with the correct formulas, hadn't changed since then. So if you think about it, why would I want to sit there and reprogram that each time? That would be put off into another library. And that's what this math is. You see it says class system.math. If I right click on it, I can do a go to definition. And you see that they've written programs to handle a lot of this. Truncate, so forth. If I had access to this file, and it won't let me access this file when we change it, but if I had access to this file, I could put my own function in here. We'll eventually see how to create our own separate libraries like that. Okay, so let's run it now. And I'll put 1 in. What am I going to put? 5 and 6. Click calculate. It didn't work. That's interesting. I would at least expected an error. Oh, I didn't make them visible. Okay, let's try that again. LB underscore x1 dot visible equals true, and LB underscore x2 dot visible equals true. Okay, so I'll run that. And 1, 5, 6. That should give us -2, -3, I believe. Okay, so it does. So it checks. If I put this in here, gives me these values. Put 2,222 in here and click that. Comes up and says NaN. That stands for not a number. The reason why is you can't have a negative inside of a square root. Don't worry about that. This isn't math class, but that's a requirement. And how you can handle that is you can program it, so you can check for that. Instead of letting it come up with an obscure number like that, you can put an appropriate message on the screen, perhaps. You might think that you don't need to worry about that, that a lot of that's handled for you in packages, that they program that in. And I'm going to show you how to program that in. But I was working with a package over the weekend, Blackboard, actually, and I was doing the quadratic formula, and I was doing it over based upon a formula, same formula you see here, and it wasn't working. And I'm sitting here, I'm scratching my head, and I'm thinking, well, this doesn't make any sense. Why isn't this working? And it's because it wasn't giving me an error message, just wasn't working. It wasn't giving me an error message, but it didn't know how to handle this. The programmer had not programmed that correctly, and so it was just coming up blank. It took me a while, and then I hit my head, and it was a math course I was developing. So some of these are not as intuitive as you think, and then programmers don't plan. They don't think to program that. It was under course tools and tests and surveys. I was creating a test. By the way, if you see this out there, you shouldn't. It's only if I deploy it. But if I do a calculated formula, this is where you come up and you put brackets for the A, B, C, and then I can only check one of them at a time. And then your X1 here. And I think I got that all messed up. Let me think. Yeah, you're going to enter A, B, and C in. Okay, it's going to return X1. So down here, that's where I put my beginning parentheses for the numerator. And then I put -1 times B plus, and in this case, I had the square root. And then I put in my B squared, and it had a little bit more functionality. Minus 4AC, closing parentheses for the top, divided by beginning parentheses 2 times A for the bottom. And we got that. So now, if I went to the next, I then came over here, and it generates values for A, B, and C. So I could put anything here. And I rounded to 2 decimal places, and then I think I changed this to 40. And I chose calculate. Now I might be working on this one. It did not work on the version of Blackboard I was using, which wasn't Kali. Notice it's just not working. It's just not coming up. This is where you would expect a programmer to put an if statement in here to handle that. Like I say, it was an easy fix once I realized what it was. I just controlled the values of A, B, and C such that I didn't come up with that situation. So here, we're going to check. I'm going to put an if statement here. If math.pow of B squared minus 4 times A times C is greater than 0. Then I'm going to go through and calculate these. So I'm going to put a beginning curly bracket here. The closing curly bracket has to be after this one. Else, then I'm going to say x1 equals imaginary answer. And x2 is equal to imaginary answer. I don't know why I got the little red squigglies there. Probably because x1 and x2 are numbers, aren't they? Yeah. Okay, so I don't want that to be x1. I want maybe to be my label here. Which means you have to figure out where to put this at. And that's part of programming. Is you're sitting there struggling. Well, it isn't working. What do I do? Well, these 2 lines of code here have to be within this if statement for it to work. So if I move these up, it's within there. And instead of x1, I just simply want to drop it right into the label. Label underscore x1.text equals that. LB underscore x2.text is equal to that. Okay, let's see if that works now. Then I'll talk more about what everything means. Okay, so I got pick values. B should be small and C is huge. I should create an imaginary number. And see how it says imaginary answer. This is what they should have done in Blackboard. Took me all of 5 seconds. If 5 seconds, maybe longer, maybe 20 seconds. But if they had done this, then this would be a result that I could understand if I was a math person. If it said imaginary answer here instead of a number, then I would know. What I had to do is, once I figured out what that was, I'm demonstrating this not to show you some bizarre thing in Blackboard. I'm showing this because you have to think about the proper programming. I think I want A to be small. 3. I want C to be small. Now my last one is 4, B squared minus 4AC. 4 times A times C. 3 times 3 is 9, times 4 is 36. So this has to at least be 6. And then it can go up to whatever. So now if I click calculate, assuming I've thought this through correctly, I haven't. Oh, no, it did pop up. Just a little slow. Pops up with numbers. So again, when you're designing a program, you have to consider these items. You don't have to be a mathematical genius. In 13 years of programming, the hardest thing I would program, I programmed math-wise, is I think it was either rolling average or moving average. I don't remember what they call it, but it's basically a fancy average based upon where it is in the report. Pretty easy to program. Anytime there's anything mathematical, accounting-wise, I didn't understand, I would have them give me an example, and that's your best thing. Work it out on paper. You go to a user and they say, "I want you to program the sum of the financial percents." You're sitting there, what in the world are you talking about? And then you say, "Give me an example." You say, "Where's the data come from?" And so they give you where the data comes from. And then you ask them work a hand example. If you can see a hand example, you can implement it. For the most part. There was one case where I couldn't. That was one of the companies within Coke. For the most part, Coke Industries hired and probably still hires top-notch people. They know what they're doing. And that's true in about every department except for this one department. And they just really lacked accounting knowledge. It was shocking. And I created some reports for them. They didn't really give me that hand example like I wanted. So I wasn't quite sure about the formula. I wasn't quite sure about what I had implemented. Because I'm not an accounting major. I had a couple accounting classes. I could maybe tell you the difference between a debit and a credit. Maybe. And I had implemented this report. I sat down with them because I wanted them to tell me if the data was right. I was really concerned about that because they weren't able to give me that example. So we sat down. And they said, "Well, can you move this title over a little bit? And can you move this over about an inch? And can you bold this?" And they're going through all this, and I'm sitting there writing this down. So, yeah, I can do that. Yeah, I can do that. Got to the end. And I said, "How's the data look?" That's the only reason I was sitting in that meeting in the first place. And they said, "Oh, it's fine. That's fine." They hadn't even looked at the data. They called me up 2 or 3 months later to tell me the data was wrong. At that point, I'm sitting there with a phone hitting myself in the head. Yeah, they just didn't have that knowledge. And that was the important part. It was data correct. They're making business decisions based upon this false data. So yeah, if you can, you have them give you an example, and so then you can implement it. This one right here, this would be an example. You see how this has an I? Although they didn't put the beginning, they didn't have the A, B, and C on here. You can see B is -3, A is 2, C is 4. If I want to get more complex on this, we're not going to in this example, but you could come up with an answer like this. So you could have it printed that way. That's what you'll find at there's websites that they perform math. Mathway is a famous one. So I come here and you type in your problem, ax, well, not ax squared, x squared plus right arrow plus 2x plus 111 equals 0. You click this option here. You say solve using a quadratic formula. Gives you this answer right here. What they've done is they've gone through and done the same programming that we've done with more to it, because they're actually putting code in here to determine if there's an I, and they're also simplifying the radical where possible. In this case, I think they brought a number out, so it canceled the 2 on the bottom. But again, this is just coding you're seeing here. By the way, Mathway is just incredibly successful. Math teachers hate it. And I thought they would tell how many problems they've solved. No, they haven't. That's a shame. Huh. About. Actually, I don't know if I understand this site. Now that I go to it. Okay, there's advertisements. This is where you can take your programming expertise, and they've applied their programming here. They get tons of students coming out here using this as an aid, and they're selling these advertisements. People know that millions of people go out here to Mathway, and so they're making a ton of money on the advertisements. So if you're clever with programming and you got that marketing side to you, you can make some pretty good money. Okay, so here we demonstrated the math library. We demonstrated how to do a power, and we demonstrated how to handle there it is, how to handle a condition that's not appropriate. Okay, great questions on that program. So let me start a new one. Let's try it again. New. There. Now we've looked at labels, we've looked at text boxes, looked at putting different data types in them and so forth. There's a lot of other controls here. Let's go to list box. And I'll come over here and change its font so you can see a little bit bigger or a little bit easier on your side. And font 14. Okay, so I got a list box here and I resize it so it's big. If I right click on the list box, you'll see different items here. There's one that says edit items. It says enter the strains in the collection, one per line. Kansas, Missouri, Oklahoma, Texas, and Nebraska. And I click OK. You see we got these items here. And if I click Start, we got a list of items. And you can see I can come up here and I can click these. Like that. Well, let's say, depending upon what I click, I want to put something over here in a label. Keep wanting to resize that. I keep trying to grab it to resize it, but 14. This is gonna need to give it a name. LB underscore result. Now I'm going to program this such that I want to decide which one I clicked. Now I'll have to play with this a little bit because I don't always remember which property it is. But if I click this one time, I see the name says list box 1. I don't want to call it LB because I've been using that for labels. So let me say LBox and states. Again, give it a meaningful name if you're going to access it in your code. And let me actually put a button on there just so we see specifically programming a button. Is that a button? I'm not sure it's small. Change the font on that. 14. And I want it to say something. What do I want it to say? Click. Okay, so going to click that. It's going to update label 1. Okay, so I'm going to double click button. And now if I start typing LBox states dot, you'll see different options. You see there's an items, and that gets items of the list box. You see there's a selected index. Gets or sets a zero-based index of the currently selected item in the list box. There's also a selected item. Gets or selects a currently selected item in the list box. I think selected item might not be too bad of a choice, so we're gonna work with that. But let me go ahead and first get rid of that. And I'm going to declare a string where I'm going to retrieve state. State is going to equal to list box states dot selected item. And I suspect I have to do a toString, assuming I've chose the wrong or the right property here. Now I want to write that out to my LB result dot text is equal to state. Let's see if I'm even close. Kansas, Missouri. Now don't be impressed or anything. I just got lucky. Usually it takes me a while to pick the appropriate one. Now you could, after you retrieve state, instead of putting state out in the label, you could put some other option. For example, if I took label here and I right click on it, and choose a copy. Right click down here and choose a paste. That says label 1. This says label 1, but I want that to have a different, what's this one called? LB underscore result. I'll call this one LB underscore description. So within my code, I retrieve state. So I'm going to say if state equals, I'm surprised this worked. I thought I had to put a dot equals. Kansas LB description dot text equals Kansas is great. I like Kansas. Well, let's run that. It's got an issue, I think. I meant to put an issue in it, but we'll see if it actually works or not. Click Missouri, click that. Doesn't update this, but if I click Kansas, let's see if it updates it. It did not. Kansas, uppercase K, and then the rest lowercase. Notice that in my program here, I am checking for lowercase. One of the first database programs that I wrote, I asked them to input the state. And you'd be shocked the way people put states in. It's freeform, which is a mistake on my part. You only screw up one time like that. Some people put it in all lowercase. Some people put an uppercase K. Some people put all uppercase. Some put KS. Some put KS lowercase. Some put KS and then a period, like an abbreviation. Some people put Oz. I think after, I don't know how many days worth of work or data was out there, I got looking, I was going to run a report, and when I sorted by state, I had all these messed up lines in the report. And I realized what they had done. So I had to use SQL and go clean it up. But that's an issue. Now we're going to talk about how to handle that, but I just changed it for uppercase K right now. Now if I choose Kansas, it should work. Kansas is great. Well, how can you handle that? Well, I've let's see, state. I retrieve that. Then down here, I write out state. After I write out state, I could say state is equal to state dot. And you see that there's a lot of methods that I could put in here. To upper. This will make everything uppercase. There's a to lower somewhere. There's to lower. So now that's going to change everything to lowercase. So it means I could have this checking to see if it's lowercase. So that way I don't have to worry about getting it precise. So now if I choose Kansas, it should work. And it does. We're going to see strings have a lot of power to them. And it's just not lower and upper, but there's a lot we can do with it. Now down here, I'm going to say else if state equals Oklahoma. Text equals is beautiful. Parts of it are. Parts of it are not so beautiful. Else if state equals to, what else do I have? Nebraska. Description. No offense if you're from any of these states. Is full of corn. Let's see, what else did I have? I had Texas, didn't I? Was it just, no, I had 5. What was the other one? Missouri. Else if state equals Missouri, LB description dot text is full of trees, a lot of trees, at least in parts of Missouri. And then else, lb description.text equals to, it'd be Texas, is full of, what's in Texas, steers? We'll say steers. Okay, now I wanted to show an embedded, or not embedded, but nested if statements, and we have multiple ones, and talk about it. But first, let's see if it works. Click that. Nebraska, Texas, Oklahoma, Missouri, Kansas. Okay, all looks correct. Now, how this structure works is this, of course, converts the value that's in state or string and converts it to to lower letters, so lowercase. So then I can check if Kansas is equal to state, then it does this. If it's equal to Oklahoma, it does this, and so forth. Now, if this is true, if state's equal to Kansas, it does this one line of code here and then comes down to the end, clear down here. So this is where it dropped down to after it got done. It would not even check all these other ones because this one was true. Now, let's say originally it's equal to Nebraska. So it comes up here, checks to see if it's equal to Kansas. It's not. So else, if, it checks it here. It's not equal to Oklahoma. So it comes down here. Now it's checking this. And if it's equal to Nebraska, it prints this, and then comes down and continues right here. And there's no more of the code down there. So for Nebraska, it would do 3 checks. This one, and this one. And then it would drop down here at the end. So any questions on nesting if statements? And don't forget to unmute yourself if you do have, if you are asking questions. Now this right here, this else here means that there are no other options. So by default, it's this right here. This would work equally well if I put check to see if the state is equal to Texas. And it actually would open it up so you wouldn't break in the future. Because if I have this right here, and I come down to my items here, right click on it, and choose edit items. If I added New York, and then click OK. Now if I run this, click New York and click that. It says New York is full of steers, which isn't true. They're not a cattle state. So by using an else, it sometimes will open you up to putting errors in the future. So if you else if state equals Texas, full of steers. And I'll go ahead and put an else if here. The last one does not have to be an else. State equals to New York. There'll be description.text is full of people. A lot of people in New York. Doesn't like that for some reason. What's wrong with that? Cannot implicitly convert type string to bool. Oh, I just have one equals there. That's a real common mistake. I didn't mean to make it. But in your condition here, when you're checking equals, you have to put 2 equals. Otherwise, it assumes it's an assignment operator. And some program languages will let you do it. And then you're sitting there forever trying to figure out what's wrong. And what's wrong is you can put 2 equals. So now if I click that, it's full of people, full of corn, full of steers. Oklahoma's beautiful, full of trees. It's great. Now I want you to implement a program where you create your own list of items here. We didn't get to the average today. We'll get to that next time. But you create your own list of items here, maybe TV shows, movies, fruit, cities, whatever you want to put here. And I want you to have a click button, and then I want you to retrieve whichever one you clicked and write it out to a label. So nothing real fancy on that. I just want you to get used to using a list box. And then we'll do something more productive with the list box next time. Now, let's see, today's Wednesday. So the next class for this one is on Monday. They're reworking the room here. Nobody's here in the room, so it's not such an issue. But I will be broadcasting out of my office, so it'll look different. So it won't have the same look. Probably the quality of the audio won't be quite as good, but it should be fine. But I'll go ahead and stop the recording.